Okay, systems of linear inequalities, not linear equations. That was sort of 9.1 before. Today, we have graphed linear inequalities last time. Now today we're going to be graphing systems of linear inequalities. Anybody have an idea how that's different? Yeah.
There's going to be more than one line.
Yeah, there's going to be more than one, not line, well, inequalities, right? Yeah, it does have boundary lines and so forth. So, turns out, then how do you do this? Well, you can use graph to find the solution set of a system of linear inequalities. Okay? So write it down. Oh, wait. So, take a look at then this system of linear inequalities. X minus y greater than 2, and then x plus 2y greater than or equal to 2. As you can see, since we're talking about systems, you have more than one inequality. Okay? So, what should I do with example 1 here, the first inequality? Should I graph it as it is, or should I do something before I will graph? Ryan, what should I do?
You should move the x to the other side.
Right, and what are you trying to do when you're doing that? You're trying to write this as? Slope-intercept form, remember? Right? You're trying to get the y by itself, right? Well, it's not really slope-intercept form because it doesn't have equal sign, but you know what I mean, right? So, go ahead and everybody rewrite both of them, right? So that the y is by itself and it looks kind of like slope-intercept form, right? Instead of equal sign, you would have inequalities in there, right? So, go ahead. Just like your homework. And when you divide or multiply both sides by negative, what do you have to remember to do with the inequality symbol? You must reverse it. Okay, only when you multiply or divide by negative. Okay, not positive or anything like that. Go ahead, everybody. So did you all get this? Y less than x minus 2 for the left. Did you all remember to reverse the inequality when you subtract both sides by x? Okay, by the way, when you subtract, do you reverse the inequality symbol? No, only when you're dividing by negative or multiplying by negative, right? So there, again, on the right, the inequality on the right, the inequality symbol does not switch at all, does it? It does not reverse at all. So you just subtract x and then divide by 2. Do you know how to graph both of these? Yeah. And what would the solution then look like? Anybody have an idea? What would the solution of this system look like? One person? Paul, any idea? We talked about solution of system of linear equations, where two lines intersect. Well, in this case, are you going to have just lines, or are you going to have shaded region? Shaded region. So what would then solution of this system of inequalities be? Paul, any idea? Yeah, it'll be infinitely many also, but what would it look like? So now we have shaded region instead of just lines, right? Okay, go ahead, everybody. I'll give you time. What do you guys think? Okay, what do you guys think? What do you think this solution will look like? Now that we don't have just lines, we have shaded regions. Okay, hold on. You guys think about it. I'll give you time. Go ahead, discuss. Okay, so first of all, do you know how to graph? Do you think it's a good idea to graph them in different color if you have, if you have an option? You don't have to, but I'm going to do that so that you can see which one belongs to which. So let me first graph the first inequality. What is my boundary line, guys? Boundary line. My boundary line for first inequality is, what's the equation of my boundary line? Yeah.
Y equals x minus 2.
Good. Y equals x minus 2. It's just same thing, except instead of inequality symbol, you put equal sign. So do we know how to graph this boundary line? Y equals x minus 2. We better, right? What do we do first? William, what should I do first? Yeah, I started negative to which one? On the y-axis or x-axis? Y-axis. And it's going to have a slope of 1. Go up 1 to the right 1. Go up 1 to the right 1. I could keep going. Now, would this boundary line be dotted or solid? It'll be dotted because it's strictly less than. Isn't that right? The inequality symbol. So I'm going to put dotted line here. Okay, so let's see. Be careful when you. Okay, here you go. Are we good? Oops. There's my first inequality. Am I done with this inequality? No, you have to shade. It says y is less than x minus 2. So do I shade above this line or below? Below. It says, okay, so here's my shading point. Okay, this is the same thing as what we did before. Isn't that right? on previous section? Isn't this what we did? Now we just do the same thing for the other equation. I'm gonna do this in red. Somebody tell me what to do for this one. What about Rachel? What do I do here on the second equation? I should start at,
You start at 1 on the y-axis.
very good. And slope is?
-1/2.
Good. Slope is -1/2, so I go, what do I do?
Down 1.
Go down 1 to the right, 2, very good. I could do that again, to get a couple more points. I could go up 1 to the left 1 too if you like. And so, how about, Lisa, do I do a dotted line or do I draw a solid? Solid line is correct because it's y. Greater than or equal to, greater than or equal to, good. So a solid line like this. Now it says y is greater than or equal to -12x plus 1. So should I shade above or below this line, boundary line? It should be above, right? So let me shade it above here. So now, okay, that's great. So what does this mean? Where would then my solution be at? Audrey?
It's the part where they're both shaded.
That's correct. It's the part where they're both shaded. Just like, when we were talking about systems of linear equation, we were looking for solution for both of these inequations. Here, where are the set of order pairs that are solution for both of these inequalities? Where the two shaded region overlap. Isn't that right? Do you see where they're overlapping? Yes? Where do they overlap? Right here. So I'm going to actually even highlight this if you don't mind. For you, if you don't have highlight, or you could just make it darker, right? Indicating that that part is your solution. So it'll be gonna go like this. Is this easy or hard? Do you see that? So what do you notice about, what do you think about every point on this region, right? How many points are there in this shaded region? Infinitely many there. So like, for example, 7, 1. Do you see my 7, 1 right here, that point? Is that my solution to the system? Is that right? Is that part of my solution? What about like 8, what is that? 8, 3, is that a solution? How many solutions are there in this region? Infinitely many. There are a bunch of order. Oh, let me ask you this. Let's see. Now I want you to all think about this. What about where the two boundary lines intersect? What about at 2, 0? Would that point? Now think about this. Would that point be a solution? How many people say yes? That point where the two boundary lines intersect is a solution. A couple of you. How many people say no? That is not going to be a solution. You guys are correct. It is not going to be a solution. But you say, wait a minute, Mr. Wang, didn't we say when the two lines intersect, isn't that our solution? So forth. Well, how come that's not going to be my solution? Leah?
It's not a solution to the first inequality because that line is dotted.
That's correct. It is, even though it's a solution to the red one, the second inequality, is a solution for the first one. No, it's not, because we do not include that boundary line. It's y is less than x minus 2. Does that make sense? So if the blue one was solid line, in other words, if it was y less than or equal to x minus 2, then would that intersection be our solution? Yes, but this case it is not, because one of them is solid, the other is dotted. Do you guys understand? Yes, Sarah.
What if both were dotted?
What if both were dotted? Then there's nothing to think about. Then it's not a solution for any of those two. So of course it's not a solution. What about then, Sarah, this one? 3, 1. You see where 3, 1 is? Where it is right on this dotted boundary line? Would that be my solution? Of course not. What about this then, guys? 4, -1. How many people think 4, -1 is a solution? You see where the red dot there? How many people say it's not a solution? This will be a solution, isn't it? It's the solution, definitely for solution for the red one. Is this a solution for the blue? Yes, it is, because it includes that region. Blue region, it's every order pair underneath this dotted line. So it does include 4, -1, doesn't it? You see, do you guys understand? 4, -1 is part of your solution. Does that make sense? Ryan, what about this point right here? 6, -2. Would that be my solution? Yeah, why? It's on the red line. Not only that, that part is included in the, you see the blue shaded region? We've shaded everything below. Of course, that point is below this blue region, right? Does that make sense? Any questions? is it possible to write down all these order pairs? As I said, no. That's why we just leave it as a graph. Okay. So as you can see, this shaded part, right, is your solution. Set of your solution. Set of solution. Does that make sense? May I move on? Can you do something like this on your own then? Try this one here. Example 2. What if I give you these simple equations? Inequalities, I mean. Y greater than 1 and x less than 3. What would the solution for these inequalities be? Everybody go ahead and try. Give you time. So, first of all, do you all agree that my boundary lines for these inequalities are y equals to 1 and x equals to 3? That's simple, right? Just boundary line, just replace the inequality symbol with equal sign. That's just our boundary lines. What does y equals to 1 look like, guys? How do you graph this boundary line? Ethan? It's a horizontal line. Very good. What can I do to remember that it's a horizontal line? Can I do a little table if I wanted to? Yeah, y is always equal to 1, right? X could be anything you want. What about x equals to 3? What kind of line is x equals 3? Vertical line. What if you forgot about that? Well, you could do a little table like this to remind yourself. Is that okay? All right. So, if you check and see if you have this. Okay, let's move on. Then, anybody have any questions so far? Okay. So so we just noticed that y equals to 1. The boundary line is a horizontal line. Is it going to be dotted or solid? What do you guys think? It'll be dotted. So let me do it with blue again, the first one. Because it says y is greater, right? It doesn't say greater than or equal to. Is it going to be above this line or below? Above. Y is greater than 1. Any number that's greater than 1 is going to be above this line. So there you are. What about the other one here? X is less than 3. It's going to be, oh, okay, so let's graph the boundary line first. Lucia, what do I do? It's a vertical line, isn't it? So, is it going to be dotted or so? Vertical line x equals 3. Is it going to be dotted or solid? Dotted is correct. It says x is less than 3. And class, is it going to be, now you can't be above or below this line. It's a vertical line, so it's got to be left or right. Would it be left or right? Or it would be? A lot of you guys graphed right and got it wrong. It says x is less than 3. So where are all the values that are less than 3? Left, okay. I saw some of your graph. You guys shaded to the right. I don't know why. It says less than 3. So as you can see, do you see where the two regions overlap? Let me highlight that part for you. Here. It's this side. Some of you had the other side. That's wrong. Okay, it's right here. Go ahead and fix it if you got it wrong. So do you see what you did wrong there? So that region is your set of order pairs that happens to be true for both of these inequalities. Let me ask you this, class, then. What about this point right here? 3, 1. Would that be my solution, Sarah? 3, 1. No. Sarah, hey, what about 3, 2? No. What about 2, 3, Ben? Yeah, anything in this region would be your solution, right? A bunch of order pairs. But anything on the dotted line, of course, it's not going to be your solution. Does that make sense? Okay. Is this clear? What about 4, negative 2? Is that my solution? 4, negative 2? No. What about 5, 3? Is that my solution? Of course not. It's not. Well, it's solution for the first inequality, but it's not solution for the second. What about 3, negative 3? Oh, 3, negative 3. Oh, right here. What about 3, negative 3? On the boundary line? No. Claire, what about, I don't know, 1, negative 1, negative 1? No, of course not. Okay, anything in this region is your only solution, okay? With a system of inequalities. Are we good? Just pretty straightforward. Okay, may I move on? Okay. Now, I want to show you another example. We're going to do it kind of backwards. I'm going to give you a graph of this systems of inequalities, and I'm going to show you where they overlap. Guess what you're going to have to then tell me? You have to give me the inequalities, the systems of inequalities. Here's what I mean by this. So, hold on. So here's what I mean by this. This is really straight from your homework. It says write the system of linear inequalities whose solution set is shown by the shaded region. You see my shaded region? If that's my shaded region, in other words, if that's my solution, can you tell me then which systems of inequalities, right, gives you that part of region as your solution? Does that make sense? So we're going kind of backwards, right? Now I'm giving you the solution. Can you tell me which inequalities, right, makes up this solution? Which systems of linear inequalities? Go ahead, everybody, figure this out. I'll give you time. We're kind of doing it backwards now. What do you think? First thing we should do is, if I want to know which inequalities gives us that region as our solution, what do you think we should do? What do you think we should figure out first? Yeah. The boundary lines. Very good. So do we know how to find the boundary lines of these? What are so step one? I'm going to write it down here. Find the boundary line for both inequalities. Okay. And that's not bad. That's not too hard. What about for the blue one? What would you do? It's a vertical line. Look at all the order pairs. What do you guys notice about all the order pairs on this blue boundary line? For example, look at this order pair right here. It's 2 what? 2 1. What about this? 2 2 2 3 2 4. What about this one? 2 negative 1 2 negative 2. What do you guys notice about x coordinate? Yeah. X is always 2. What's the equation of this boundary line? X is equal to 2. Do we know how to find the y-intercept of this line right here? Yeah, it says right there. What is it? What's the y-intercept of this red line? 3. What's our slope? You go down 2 to the right one, go down 2 to the right one, negative 2. So what's the equation of this red boundary line? Who could tell me? Don't all go at once here. How about, yeah, Victor? Y equals to negative 2x plus 3 is exactly right. You see? Right, my slope is negative 2, my y-intercept is 3. I know that for the blue one is x equals always 2. Now, are we done? What's our step 2? Step 1 is to find the boundary line of these inequalities. What do you think our step 2 is? Yeah. Yeah, you figure out what's correct inequalities for these, right, shades. So, for the blue line, do we need to shade to the right or the left, you think? So that this part is your solution. To the right. So therefore, x has to be what? Greater than 2. Is it going to be greater than or equal to 2 or just greater than 2? Just greater than 2. It's dotted. What about the red one? In order for this shaded region to be part of your solution, do I have to shade it above or below this line? Below, so y has to be what? Y less than or equal to, because it's solid, right? Do you all agree? So how many people got, so write the correct inequality. How many people got these two inequalities? Raise your hand. Oh, not? Oh, okay. Good. Any question? How many people did not get these? How many people have any question? How many people see the mistake that they made now? Is this pretty straightforward? Yes. You did? Okay. Very good. Do you think you could do something like this for your homework tonight? Yeah. Okay, that's what you're going to have. Okay, good. Good.